TurboCell targets AI's power infrastructure gap. The rapid expansion of AI infrastructure is exposing a structural mismatch. Compute capacity can be deployed in months, but grid upgrades and utility interconnections often take years. As hyperscale operators accelerate plans for multi-hundred megawatt and gigawatt scale campuses, access to reliable power has become a primary constraint. Endeavor's TurboCell platform enters this environment as a modular power system designed to shorten time to power while supporting long-term operational flexibility. Rather than acting as a temporary bridge solution, the company positions TurboCell as infrastructure that can evolve alongside a facility's growth trajectory. AI clusters are no longer scaling in predictable increments. Large training environments can jump from tens to hundreds of megawatts in a single expansion cycle. That growth pattern demands systems capable of delivering capacity quickly while maintaining performance under highly dynamic load conditions. TurboCell is designed to provide prime power during early deployment phases, then transition into a long-term backup role once full utility connections are established, an approach intended to reduce stranded capital and extend asset value. Stabilizing volatile AI workloads. AI training introduces electrical stress profiles that differ markedly from traditional enterprise IT. Thousands of GPUs ramping simultaneously can generate abrupt megawatt-scale swings in demand. These fluctuations may cause voltage deviations and frequency instability, increasing the risk of equipment stress and operational disruption. TurboCell addresses this through a hybrid DC-based architecture that integrates high-speed generation with battery buffering. The system is designed to manage millisecond-level load volatility at the source, limiting transients before they propagate to GPU racks, on-site generation assets, or the broader grid connection. Power quality is treated as a core engineering requirement rather than a secondary layer. By smoothing rapid demand shifts, the platform aims to support consistent performance during large-scale training runs, where instability can translate directly into downtime and financial exposure. The physical architecture emphasizes modularity. Standardized units are configured to reduce the size of failure domains and simplify maintenance. With fewer moving parts than traditional centralized generation systems, the design prioritizes fault isolation and high availability in hyperscale environments. Deployment speed, permitting, and long-term flexibility. Beyond technical performance, AI operators face strategic decisions around capital timing. Committing to large-scale power infrastructure before workloads are fully defined can introduce risk. TurboCell's modular configuration allows capacity to be added incrementally, aligning power investment more closely with actual demand growth. This approach also enables reallocation of deployed units as facility needs evolve, supporting phased campus builds or changing workload mixes without full system redesigns. Permitting and emissions compliance are additional considerations, particularly in regions with tightening air quality regulations. TurboCell is positioned as an alternative to conventional diesel-heavy backup strategies, with lower reported NOx emissions and multi-fuel capability. The system can operate on natural gas, diesel, or hydrogen, offering optionality as decarbonization requirements and fuel strategies shift over time. The broader market context underscores the urgency. U.S. data center electricity demand is projected to more than double by the end of the decade, driven largely by AI workloads. As a result, manufacturing lead times and deployment speed are becoming strategic differentiators. TurboCell is scheduled to begin shipping in 2026, with U.S.-based production planned to scale toward multi-gigawatt capacity. Orders are currently open for 2027 delivery. For operators navigating grid delays and escalating AI demand, modular, rapidly deployable generation is increasingly viewed not as supplemental infrastructure, but as a core component of competitive strategy.